Good evening. I'm Christopher Alakel. Tonight we're going to be talking about the city's existing sources of supply and our distribution system, and hopefully answer some of the most common questions and concerns that we're hearing from the community. Specifically, do we have enough water? And water rates, what am I paying for? Principal tools we use to answer these questions are the Urban Water Management Plan. There we assess the community's supply and demands. The Water System Master Plan. System Master Plan identifies the distribution system deficiencies, any existing deficiencies that need to be corrected, and also identify infrastructure that needs to be installed to support growth. And then finally, rates and fee studies to ensure that we've got the revenues coming in order to maintain that system and expand that system as needed. So let's first talk about sources of supply. The city of Paso Robles has three primary sources of potable water, actually only three sources of potable water: the Paso Robles groundwater basin, the Salinas River, and Lake Nacimiento via the Nacimiento Water Project. Each of these sources have their own unique weaknesses and challenges, and we'll talk a little bit about that. First, the basin wells. The basin wells are a network of wells scattered across the city's across the eastern side of the city. The thing that makes the basin well so important to the overall reliability of our water system is the fact that they all are dispersed. There's no single event, catastrophic or otherwise, that's likely to occur that would prevent us from utilizing that source of supply due to the fact that it's spread across such a large area. It's also a buffer to drought. In times of drought, when surface water is not plentiful, we can rely on groundwater that's in storage. The big challenge with basin water is it is under significant stress. It's been in a chronic and sustained state of decline for some time. And we can see exactly who's pumping and how much, just to get an idea of what we're talking about. Agricultural pumping accounts for about 80% of the pumping in the basin. Municipal pumping is 13 to 15%. And that municipal pumping includes not just Paso Robles, but all the communities in the basin. So that includes Templeton, Atascadero, San Miguel, et cetera. Salinas River. The Salinas River is an excellent source of supply. It can provide a significant amount of water to the community, upwards of half of the summertime demand. However, it's entirely dependent on annual precipitation. It recharges very quickly. When rain falls over the watershed, it makes its way to the river, and it's immediately available to be put to beneficial use. But however, just like it's immediately available when it rains, when it doesn't rain, it dwindles pretty quick. So it has a much higher susceptibility to drought than, say, the groundwater basin. The Nacimiento supply. While the reservoir itself is the watershed around Lake Nacimiento is highly productive and produces an enormous amount of water, hundreds of thousands of acre feet a year, the supply itself is somewhat susceptible to disruption. And that's because it's conveyed via a single pipeline from the reservoir to the community. And we've had, over the years, multiple disruptions in that supply, either due to operator error, mechanical failure, or an unwitting contractor boring through the center of the pipe. All those things have happened, and some of them more than once in a single year. So I think of those supplies as that three-legged stool. Together, they make a very reliable, sustainable source of supply for the community. However, if one of those legs is gone, now all of a sudden it's a very delicate balancing act, and it will subject the city to regular supply disruptions and potentially water shortages. So we talked a little bit about supply. Now I'm going to talk a little bit about demand. We're often asked, how do you know how much water is going to be used in the future? How do you guys project demand? So what we do is we look at land use, and specifically water consumption based upon land use category. So we look at the historical use, we get an estimate of how much an acre of land of a specific land use will use, and then we use that historical consumption to project demands into the future. And that's what this map shows here. So the circles, well, let's just talk the colors first. The colors represent the specific land use type. This is just a blow-up of a small section. The circles represent existing demand. The triangles represent future demand or expanded demand. The size is representative of the quantities that are being projected for that parcel. So what are those demands? At build out, let me show you, let me just explain this a little bit. On the left column here, this is the demand projection in acre feet per year, and this is the calendar year through build out. Expected build out right now is year 2045. At build out, we're expecting to see our communities demand around 9,500 acre feet per year. The blue, this is existing demand. We see that dropping off just a little bit as we move through build out through, this is existing customers, demand from existing customers dropping off due to improvements in water use efficiency. The orange, that's the incremental increase in demand associated with growth.
What's an acre foot?
An acre foot is enough water to cover an acre of land 1 foot deep. It's about 370,000 gallons. So that's a demand projection. This is historical water use in the city of Paso, just for comparison. So you see back here in the 80s, our estimated population over here was probably around 14,000 people. Around 10,000 people, I'm sorry. And our demand was somewhere around 3,500 acre feet. So we have water production over here, and we have population over here. The orange is our population growth over time, and the blue line is our water use over time. And you see in the last 10 years a significant reduction in the community's use of water. So that brings me to water conservation. I like this slide. Let's talk a little bit about it. So you see in 2007, community's water demand was about 7,500 acre feet per year. In 2017, it was around 5,300 acre feet per year. Now, where is all the savings coming from? If you look at the color, if you look at blue and green, combined, these two colors make up residential water use. The green is the outdoor water use, the blue is the community's indoor water use. So you can see in 2007, we were about 4,500 acre feet per year for residential use. In 2017, it's probably around 2,700 acre feet or so. Significant reduction in the residents' use of water, significant improvements in water efficiency and landscape irrigation. Similarly, we see smaller reductions in some of these other categories. The only place we see an expansion is in commercial, industrial, institutional use category, and that could be expected as the services and industry have been increasing over that 10-year period. So let's put some numbers to it. Between 2007 and 2017, our population has grown 7%. Yet we're using 30% less water, 35% less water on a per capita basis. So do we have enough water? The answer is yes, and let me show you. So you remember, this is our water demand. And these are the supplies we're going to use to satisfy that demand. We'll talk about it a little bit. So groundwater, remember groundwater was that source of supply that we know is in heavy stress and has been in a chronic state of decline. So the community, understanding that, is not relying on groundwater to grow. Our use of groundwater is going to stay constant as we move through build-out, on average. Okay? The way we're going to grow and the way we're going to expand is through the use of surface water supplies. Increased use of the river water supply, and also the increased use of the Nacimiento supplies. In addition to bringing recycled water online. Recycled water can be thought of not as so much as a potable supply, but a reduction in potable water use or a potable offset. So to recap, evaluated demands, we evaluate supply and reliability, and we've confirmed that our supplies are sufficient to satisfy the community's needs through build-out. And we regularly revisit these to assume that our assumptions are correct and to account for changes. So a few words on water rates and connection fees. We have two sources of water in the water fund. We have water rates and connection fees. Water rates is that revenue that's generated through the sale of water, through you guys paying your bill every month. Connection fees are those one-time expenses paid by development at the time of development. So water rates are used for the operation, maintenance, and replacement of the existing infrastructure. This map here shows just kind of a skeleton view of all the city mains. There's 174 miles of pipe, 11,200 service connections, 5,000 valves, 1,850 hydrants, 20 wells, 2 water treatment plants, 4 reservoirs, and 7 pump stations. That's what your water bill goes to, operating and maintaining these facilities. I like this graphic. I just threw it up because I like it so much. This shows all the facilities other than pipe, all the infrastructure we have in the water system, excluding the pipe. So it shows the reservoirs, the pumps, the arsenic removal systems, the treatment plants, etc. So connection fees. Connection fees now, that's gross buy-in to the existing system. So the community has invested in this infrastructure, and when someone wants to develop or someone wants to connect to that existing system, they have to buy into it. They're buying capacity in that existing system if it's available. If it's not, they have to pay to upgrade it. In addition, they have to fund any system improvements that are necessary to satisfy their development and future capacity improvements. So as we look, as certain areas develop more and more and more, although one specific pipe might not be necessary to serve that development, as that area grows, those pipes may need to be installed for example, for fighting fires or to have emergency storage on hand. And so they'll all pay into a fund to eventually build that when the need arises. So we regularly analyze expenses to determine that our revenue needs are being met. We'll confirm residents are not overcharged or undercharged, and that development is paying their fair share. And just to kind of get a sense of where we sit relative to the other communities in our area, Paso Robles sits pretty much right in the middle. So what we're seeing here is your total monthly water bill, and then you got different communities here on the bottom. And for someone who uses 1,300 cubic feet a month, and for the city of Paso, we call those units or billing units, 13 units, your bill would be $74.63. And that still comes to be less than a penny a gallon. In fact, that's more like 3/4 of a penny per gallon. Now we'll let Matt talk a little bit about recycled water.